What's up guys, welcome back to a brand new video for Algebra 2, and today's video will be on properties of real numbers, and this is under the linear equations unit. Before I get started, make sure you drop a like and subscribe down below, and if you have any questions, leave a comment. Feel free to leave a comment and I'll get right back to you. So let's get right into it. So real numbers, they have several subsets that are related in particular ways, and those subsets, they include rational numbers, integers, whole numbers, and natural numbers. So as shown in this chart, each real number, they have one point on the number line, and every point on the number line represents exactly one real number. So as you can see in this chart, each real number represents a point on the number line. So real numbers are classified into rational numbers and irrational numbers. And a rational number can be expressed as a ratio, for example, m over n, where m and n are integers and n is not 0. If n was 0, the denominator, if the denominator n was 0, it would mean that the number is undefined, which doesn't count. And rational numbers also have a decimal form that is terminating or repeating. So when a number is terminating, that just basically means that it has a digit that ends and stops. So for example, 1.7 is terminating, and when a number is repeating, that just means a group of digits keep repeating on and on forever, and those count as rational numbers. But on the other hand, irrational number, it doesn't terminate or repeat. So for example, pi has numbers and digits that keep repeating on and on forever without stopping, and that would mean that it's an irrational number because it doesn't stop or repeat. So subsets of rational numbers include integers, whole numbers, and natural numbers. And integers are basically whole numbers, but it includes the negatives of those numbers. So whole numbers are numbers you can count with your fingers, and which means that it doesn't include decimals. But natural numbers are whole numbers, but it doesn't include 0, because whole numbers include 0, but natural numbers doesn't include 0. And I just want you guys to keep in mind that the square root of any number is either a whole number or it's irrational. For example, the square root of 4, which is equivalent to 2, is a whole number, but the square root of 5 lies somewhere in between 2 and 3, and that must mean that it's irrational. And I have this chart to help you guys visualize how the subsets relate to each other. So take a look at that for some time. So I finally have some examples for you guys to do, and before I reveal the answers to these examples, make sure you can stop the video and try it out yourself, give it a shot. And this one will be on classifying numbers. So we have to name the sets of numbers to which each number belongs. First up, we have the square root of 16. The square root of 16 is also equivalent to 4, and as you guys know, 4 is a natural, whole, integer, rational, and a real number. We have negative 185. This is a negative number, so that must mean that it's an integer, rational, and a real number. Good job if you're getting these right. We have the square root of 20, which is a square root. So this number lies somewhere between 4 and 5, so it's not a whole number, which must mean that it is an irrational number, and that means it's a real number. Let's do some more. We have negative 7 over 8. This is a fraction, and it's also a negative number, which must mean that it is rational and real. Next up, we have 0.45 repeating, and the bar over the 45 indicates that these digits repeat forever. And remember, when digits repeat forever, it counts as rational numbers, and which means it's also real. So let's talk about the properties of real numbers. And I have this chart so you guys can know some of the properties. So the properties are commutative, associative, identity, inverse, and distributive. And as you see here, these properties come with the addition and multiplication part of it. So the commutative property basically means that no matter how the numbers are ordered, it will still have the same result. So an example is a plus b is also equal to b plus a. You see these numbers are flipped, but it's still equivalent to each other. And that's also the same for multiplication. A times b is equal to b times a. These numbers, these expressions still have the same value even if the order is flipped. The associative property basically says that no matter how numbers are grouped together, it would still have the same value. So parentheses a plus b plus c is equal to a plus parentheses b plus c. And that goes for multiplication too. Parentheses a times b times c is equal to a times parentheses b times c. Now the identity property basically just states that any number that's added by 0 will still preserve its identity, will still preserve its value. So a plus a is still equal to a. And that's for multiplication, but instead, any number multiplied by 1 will preserve its identity. So we have the inverse property. So a number's inverse is basically the number that if you were to add it together, it would give you the number 0. And as you can see, a plus negative a would still give you 0. And for multiplication, if a is not equal to 0, then a times 1 over a is equal to 1. So that means a number multiplied by its reciprocal, so which means that you just flip the numerator and the denominator, would give you 1. And that's for multiplication. And in distributive property, basically means that if numbers are repeating, you can put it in a parentheses and you can multiply it across several numbers. So for example, a parentheses b plus c is equal to ab plus ac, and ab plus ac basically just means a times b plus a times c, and parentheses b plus c times a is equal to b times a plus c times a. So that's basically the distributive property. So again, I have some examples where you identify the properties of real numbers, and you just have to name the property illustrated by each equation. Again, give it a try before I reveal the answer. So first up, we have parentheses 5 plus 7 plus 8 is equal to 8 plus parentheses 5 plus 7. So this would be the commutative property of addition, because the order in which you add does not change the sum. Next up, we have 3 times 4x is equal to 3 times 4x. But the first part of it is in parentheses. So this would be the associative property of multiplication, because the way you group these numbers when multiplying does not change the product. So I have example 3, the additive and multiplicative inverses. So I want you guys to identify the additive inverse and the multiplicative inverse for each number. So again, you can give it a shot before I reveal the answer. So what is the additive inverse and the multiplicative inverse for -1 and 3/4? So since -1 and 3/4 plus 1 and 3/4 is equal to 0, the additive inverse of -1 and 3/4 is basically 1 and 3/4. So the additive inverse of a number is just with the opposite sign of the number. And for multiplication, since -1 and 3/4 is equal to -7 over 4, -7 over 4 is the improper fraction of -1 and 3/4, so they have the same value. And -7 over 4 times -4 over 7, which is reciprocal, is equal to 1. The multiplicative inverse of -1 and 3/4 is -4 over 7. Okay, next up we have 1.25, and since 1.25 plus -1.25 is equal to 0, the additive inverse of 1.25 is -1.25. And the multiplicative inverse of 1.25 is 1 over 1.25, or 0.8. So I just put a 1 in the numerator and the 1.25 in the denominator. And that's its multiplicative inverse. And that's also 0.8 in decimal form. And 1.25 times 0.8 is equivalent to 1. So I have this word problem for you guys to do using distributive property to solve a problem. So let's read it. A restaurant adds a 20% tip to the bills of 6 or more people. Suppose a server waits on 5 such tables. The bill without the tip for each is listed in the table shown below, so right here. And we have to find out how much the server makes in tip during his shift. So we have 5 tables, and this is how much the bills are. So first off, we can take 0.2 times 185.45 plus 205.20 plus 195.05 plus 245.80 plus 262. And these are just the cost of the parties of the tables. And I'm just multiplying that by 0.2 because that's how much we're supposed to take the percent for the tip. So the decimal form for 20% is 0.2. So that's what we multiply it by. And then we add what's in the parentheses, and that would give us 1093.5. And if we finally multiply, that will give us 218.7. 0.2 times 1093.5 is 218.70. So the server made $218.70 during the shift. So example 5 is simplifying an expression, and we have to simplify 2 parentheses 5m plus n plus 3 parentheses 2m minus 4n. So first we actually have to distribute the 2. Let's distribute the 2 across the 5m and the n, and that would be 2 times 5m plus 2n. And if you distribute the 3 across the 2m minus 4n, that would give us 3 times 2n to 2m minus 3 times 4n. And this is using the distributive property. So if we simplify that further and multiply, 2 times 5 would be 10. And if you bring down the m, it will give us m, 10m plus 2n plus 6m. 3 times 2m is 6m minus 3 times 4n, that will give us 12n. So we can use the commutative property to switch up the orders of the numbers to make it easier for us to distribute further on, and that would leave us with 10m plus 6m plus 2n minus 12n. And if we use the distributive property, we can take out the m that repeats across the 10m plus 6m and then put it outside the parentheses, and we can do the same for the n and the 2n minus 12n. So that will leave us with parentheses 10 plus 6m plus parentheses 2 minus 12n. And if we simplify, that will give us 16m minus 10n as the final answer. So I have some practice questions for you guys to do. I would leave the answers to these questions in the description down below. And give this a shot if you guys want. It would be really helpful. And that's the end of it. So make sure you guys like and subscribe before you go. Leave a comment if you have any questions, and I'll get back to you. Peace out.